In this video lecture, let us look into the detailed explanation for nanomaterial synthesis by chemical vapor deposition. What is CVD? Chemical vapor deposition is a technique used to produce nanoscale thin films and nanomaterials on a substrate surface. Vapor precursor molecules containing the required atoms are introduced into the reactor. These molecules react or decompose specifically on nanocatalyst particles present on the heated substrate. When these precursors decompose, the released atoms attach and grow on the nanocatalyst, forming solid nanostructures such as nanotubes, nanowires, or nanothin coatings. Because the growth starts at nanometer-sized catalyst particles, the deposited material naturally forms nanoscale structures instead of bulk films. Using CVD, we can synthesize carbon nanotubes, nanowires, ceramic nanolayers, metal nanofilms, and other controlled nanostructures with high purity and uniformity. Parts of a CVD system. Reactor tube. Usually it is made of quartz because it can withstand high temperatures, and this is where the substrate, catalyst and gases interact and provides a controlled environment for nanomaterial growth. Furnace or heating system surrounds the quartz tube, maintains high temperatures at around 500 to 1000 degrees Celsius required for precursor decomposition. Uniform heating ensures proper nanostructure formation. Gas inlet system introduces precursor gases, example methane, acetylene, metal organic vapors, introduces carrier gases like nitrogen, hydrogen, argon, and controls the flow rate, which decides the size and quality of the nanoparticles. Precursor source, a cylinder or bubbler containing the chemical vapor precursor, provides the atoms that will form the nanomaterial. Example, methane for CNTs, titanium precursor for titanium dioxide nanoparticles. Substrate holder holds the substrate, that is silica, quartz, mica, or metal foil can be used. Often coated with nanocatalyst particles, nickel, cobalt, iron. Nanomaterial growth begins here. Nanocatalyst particles. Very important for nanomaterial formation. Usually iron, nickel or cobalt nanoparticles can be used as a catalyst. They determine the diameter, length and structure of CNTs or nanowires and act as nucleation and growth site. Gas exhaust or outlet removes unreacted gases and byproducts, keeps the reactor safe by controlling pressure, prevents contamination of the nanostructures. Working principle: a substrate is placed inside a reactor. Vapor precursors are sent into the chamber. The substrate is heated to a high temperature. At this temperature, the vapor molecules break down, that is, decompose. The required atoms settle and deposit as a thin solid layer on the substrate. Here the substrate, consider the carbon atoms, it settles over the nanocatalyst and it forms a nanotube. By controlling temperature, gas flow and catalyst, we can get nanotubes, nanowires, thin films, etc. Working principle key idea. The gas molecules decomposes and form solid nanolayer on the surface. Why CVD is useful? Produces high quality, uniform and high purity nanomaterials suitable for industrial mass production, good control over thickness, structure and size. Types of CVD. Thermal CVD uses only heat to break the precursors. Temperature range is 800 to 2000 degrees Celsius, most commonly used. And types of CVD subtypes: high or low temperature CVD, atmospheric or low pressure CVD, hot wall or cold wall reactors, open and closed CVD systems. And plasma enhanced CVD uses plasma to activate the reaction, that is ionized gas, works at lower temperature around 300 to 700 degrees Celsius, useful for heat sensitive materials. Laser CVD, a laser beam heats the substrate. Reaction happens only at the laser hit area. Very precise deposition. Photo CVD or UV CVD uses UV light or photons to break molecules. Reaction occurs at room temperature, gives ultra pure films. Thank you for watching this video lecture.